In this video, I will answer 10 questions on hyperbolic functions, finding the derivative of hyperbolic functions. So previously we answered the the derivative of inverse trigonometric functions. Now we're doing hyperbolic. So these are the formulas that we'll be using. So yeah, in every question I'll write the formulas anyways, so please be guided. So for number 11, it's already been given. So the derivative of cosine hx is equal to sine hx times du over dx. So let's use u. Okay, so u is identified to be 3x. The derivative of u is going to be 3. So sine h and then u is going to be 3x times the derivative d over dx. This is the derivative of this one, which is this. So just times 3. So the answer is going to be 3 sine x 3x. Confirm? Let me see if the answer is correct. Yes, it is. So, you might ask why wouldn't it be this or, well, yeah, why isn't the answer this? You just cannot multiply the u with anyone else. That's basically the explanation to that. You just cannot. It's not right. For example, 2 cosine 2t. So this came from a difficult question in the past. I don't know if I'll be able to answer it on YouTube, but you cannot say that it is 4 cosine t. This is not right. It's just this. Leave it as it is. Okay. Number 12, f of x is equal to tan h and then x raised to 2 minus 1. So this entire chunk is our u. What is the derivative of tan hu? That is equal to secant hu, well, just squared. So, and then times du over dx. Okay, let's identify the u. U is equal to x squared minus 1. How about u prime? That's going to be equal to 2x. Okay? And so the answer is going to be okay, number 12 is 2x secant h raised to 2x. Okay, this is correct. All right, number 13. F of x is equal to sine h raised to 2x. Okay. The derivative of sine hu is equal to cosine hu times du over dx. So our u is identified to be, okay, what's going on? Why is there a raised to 2? Let's say the u is x and then the u prime is going to be 1. If there's a raised to 2, let's see. Cosine h raised to 2 and then u is going to be 1. Sorry, it's going to be x. U prime is going to be 1. So is this the answer? Let me see. Nope. Okay, let me find a different way of solving it. Let's use chain rule. I think that's the only step. that's relevant. We can rewrite fx as like this. So bring down 2. Okay, so in that case, these are still true. What now? Okay, 2 times the derivative of this, which is this, d over dx is just 1. Okay, we still didn't get the answer. If we use chain rule, so aside from the one here, again, we multiply it by the derivative of this itself, which is cosine. So just copy that, and then we have cosine hx. So 2 sine hx cosine hx, coming from the identity. So this is going to be equal to sine 2x. Is that right? I don't think that's right. I wonder why. Answer key says it's sine h to x. Maybe, yeah, because there's no h here. Perhaps, I don't know, I don't think I've discussed this identity yet. Sine hx cosine hx is what? Okay, there's an entire set of identities only for hyperbolic. So that's insane, first of all. Sine hx cosine hx. Okay, this is... The answer is simple. Why am I still multiplying it by 2 when this entire thing becomes sine h2x? That's it. I was overthinking, I'm sorry. This is the final answer. Okay, number 14, f of x is equal to x squared secant h 4x squared. Answer. So 2x, sorry, this is, I smell a product rule that has to be applied here. So derivative of 2 raised to x is going to be 2x raised to x minus 1 times secant h 4x raised to 2 plus 2 raised to x times, okay, what is the derivative of secant h? I believe this is equal to Is it negative? I don't remember. I don't think it is negative. That's what I'm betting. Let me see if my memory is correct. Secant h, right? Derivative of secant h is equal to... Okay, I forgot there has to be a negative sign. Okay, my bad. But unfortunately, I won't be able to write it in black anymore. Okay. What's the derivative? So derivative of secant h for x squared. So this is going to be derivative of 4x squared is going to be 8x. Okay. So this is... I don't think we'll be able to answer this because I'm not familiar yet with logarithms, the logarithms aspect of derivatives. But we kind of touched this part very closely. It's this one. Ah, yeah. But, well, yeah, because this is times 2x, 2 raised to x. So we got this part correct. What about the other? What about the other part? 2x ln 2. I believe it's supposed to be this part. And then okay, this one's exactly the same as this. I guess I need to just refine my solution from there on. From there. Yeah, this is the only difference in my solution compared to the answer key solution. But essentially, this is already the final answer. So at this point, so I just have to know the derivative of 2 raised to x. So I guess it's 2 raised to x times ln 2. Where did we find ln? I know there's a formula for that, I just don't know. Mathway cannot find the derivative of this kind of question. 2 raised to x. Anyways, what's the next number? Number 15. Oops. Okay. So, what is the derivative of cotangent h? Cotangent, right? So, it has to be minus CSC raised to 2h. Yeah, I'm sure it's negative. Let's confirm if it's correct. So yeah, negative CSC raised to 2h. Okay, I think it's correct because it's cotangent. All right, and let's identify our. Oh wait, I forgot to write u. U is what? Sine x. What is the derivative of sine x? That's gonna be cosine x. This is not hyperbolic, just to let you know, because in the given, there's no h. It's just x. So yeah, negative cosecant squared h and then times sine x times derivative of u, which is cosine x. I think that's it. I don't think we can simplify any further. Cosine x CCH raised to 2 sine x. I think, yeah, this is already good. The way the answer key wrote it, this came first, then this. So basically that. But again, either way, it's still the same answer. How about number 16? F of x is equal to arc cosine of tan h square root of x. Spicy. What's the derivative? Oh, wait. Okay, so we just cosine. Arc cosine. So this is from inverse. We already have an inverse here. This is negative u prime over square root of 1 minus u raised to 2. Confirm? Is that correct? Okay, that is correct. How about the derivative of tan u? Sorry, tan h u. Derivative of tan hu is I think it's this. Let me confirm. Secant raised to 2 u. Yep. So, what do we do? So let's identify the u first. U is tan h square root of x. Simple as that. How about the derivative of it? This is where we use this formula. So it's going to be secant raised to 2. Okay, let's assume this one is a. How about a derivative of a? So x raised to 1 half x raised to negative 1 half. Or in other words, 1 over 2x raised to 1 half. So secant, this one is going to be a, alright? So it's going to be square root of x over there times d over dx. It's going to be 1 over 2 x raised to 1 half. Okay, that's essentially it. We can simplify. I don't know if we can cancel these, I'm not sure. Let's try not to for now, just to play it safe. We don't know if that's going to affect the rest of the solution. But yeah, that's this. So arc cosine negative secant squared square root of x over 2 times square root of x divided by square root of 1 minus u. U is tan h square root of x, and then raised to 2. Okay, what's next? I don't think we're gonna simplify anything else. Let's see if the answer is already correct. 16. Why is the answer different? This do not look good. What could possibly be the mistake? Can we move our solution somewhere more spacey? Somewhere with more space? So let's just write the answer key. 1 over, so this is the solution first. 1 minus tan h square root of x raised to 2. Okay, fair. Because this formula could also be rewritten as -1 over so like that. This one is this. Okay, so we multiply. Okay. This is gonna take a lot more time for me to understand. How the heck is this written? This I kind of get. This is the derivative of this. Okay, so this one is the derivative of this. Okay. This one, its derivative is this. Such that its u is this one. Yummy. This can be written as that. Below, it's gonna be, well, you can rewrite this as 2 square root of x. Huh? So coming from here, it became this. How? I don't get it anymore. But this is the final answer. Okay, number 17. F of x is equal to ln CSCH a raised to x plus 1 over CSCH a raised to x minus 1. This is logarithms. Anyways, I'll still give it a try. D over dx, the derivative of ln u is equal to 1 over u times du over dx. So 1 over u, which is this, times its derivative. Holy macaroni. Derivative of CHC cosecant h u is equal to negative cosecant u cotangent u times du over dx. May I confirm? That is correct. What is our u? Okay. We have two u's. One is e raised to x plus 1. How about its derivative? I think its derivative is just e raised to x. This becomes 0. The derivative of e raised to x is still e raised to x. Okay, what's next? That's it. I'm not simplifying anything. This is for the numerator. For the denominator, negative CSC ex minus 1 cotangent e raised to x minus 1 e raised times e raised to x. Because the derivative of this is still e raised to x, regardless of the sign, because this is going to be 0 anyways. Okay, that's it. Okay, what's next? So I think we're going to apply quotient rule. Quotient rule. So derivative of the numerator times the denominator minus the numerator times the derivative of the denominator divided by the denominator raised to 2. So derivative of the numerator is this one times the denominator. We just copy. Minus the numerator, just copy. And then the derivative of the denominator, which is this. That's long. Divided by this. So yeah, that's basically du over dx. Now, if you wanna start multiplying them now already, this is what it's supposed to look like. Yeah. All we have to do left is just simplify. Yeah, that's ridiculous. Let's just look at the answer key. Number 17. Yeah, you be the judge of that. Is the answer key the same as this one? So, yeah. I'll send this to number 18. Yeah, I think this is correct. Except I forgot d over dx. Yeah, we're not answering this. This is, for example, u raised to x. There's a property for that, but I don't know it yet. It's logarithms. It's related to logarithms. Yeah, numbers 19 and 20. Yeah, good luck with that. I'm not answering them anymore. There's no way this is gonna appear in the exam. There is no way. But yeah, that's it. Thanks for watching. This is my practice. Yeah, that's it. Bye-bye.